Okay, so here's a review of a lab that was submitted last year. I'm going to go through it quickly and hopefully give you even more insight as to what to expect from this assignment. So again, a good front cover, the people's names I've covered up, but the date is shown, and a good title. As it goes through the introduction, everything looks in place. I make a comment that you do need a real-world connection to this problem. That's also in the guidance, but unfortunately it wasn't followed. The drawing looks pretty sharp. It provides the boundary conditions and the geometry. Well done. Everything I'm pretty much following up until this point. I get to the equations and I make a comment that this is close but not completely correct. It is missing a description of the variables and in terms of units and what each variable means. So make a note of that. Here's a look at the mesh. And they make a comment that the program generates a finer mesh near the walls for greater accuracy in this region. I think it'd be smart to say why. Why does it do it? The comment here is that they move to the results and discussion section without talking about the solver, which is also in the guidance. So when you go over to the guidance and it tells you things to talk about, like here, those are all the things that need to be talked about. No more, no less. I should say more is fine, but less is not good. I make a comment, that they're imprecise with their language. They say while the flow does take a long distance to become fully developed, most of the development happens near the entrance of the channel. Try to do as much as you can, be quantitative in your language, especially when you have the opportunity. Here's also just, can you expand on a particular caption here? Help the reader is what I'm saying continually. In this one, I'm saying help orient the reader right away. Call out figures immediately. Don't write a long paragraph and then say, oh, by the way, refer to that figure. It's no, refer to the figure, then explain the figure. You want the reader to have a visual understanding as you explain it. Goes on, makes more and more plots. Once again, the idea of put the figure call out up front. Units. Unitless plots are pretty common. You want to avoid that. They're not very meaningful. So I hope that's helpful. I think I just keep saying things of that nature. And of course, you can pause this video at any moment and try to, fully appreciate what I'm trying to provide feedback on for further improvement. I did like this. That was a well done figure. The references are incomplete. They meant to do it, but didn't get it done. So that's what that circle means. Here's another set of results. Equation X. So they really didn't tighten up this document. They were almost done, but they sent in a rough draft. And they don't clarify the mesh. Again, it makes it hard on the reader if you don't know what equation X is, you don't know what mesh was used. It's hard to really take great value from this submission. More plots. So they have an error. They expect 3/2 of 4, which would be, or 0.4, which would make it 0.6, but they only end up with 0.53. That should open up some curious questions and efforts to try to resolve that. They chose not to do that. Here's a plot. They do compare, developing length with published references. They say reference 2. The phrase pressure gradients does not appear in this report. See learning objectives. So they were told to discuss pressure gradients, but they didn't do it. Um, and there's no exploration really beyond the basics for this. Um, Overall, it's a C-level type work because they miss some things, so it's incomplete in some regards. But I hope it gives you a sense of what a report looks like. And again, when I go back and try to show it, it's got a cover sheet. A lot of people like table of contents. I think it's useful to the reader, but it's not a must. It has an introduction, it has a description of the model, goes into the results and discussions that directly follow the learning objectives. And then hopefully at the end, there's some meaningful abilities to assess its accuracy. And this is one way to do it with conservation laws. You can do it with predicted theoretical maximum velocities. You can do it in many ways. And at the end, hopefully you wrap up with the key ideas, with the references, and unfortunately they didn't include Appendix 1, which is the one critical appendix I've asked you to do. I sure hope this was helpful. It's meant to provide clarity on these reports. These reports are not meant to be puzzles, they're meant to be learning tools to enhance your understanding of fluids, CFD, and obviously improve your writing abilities. So thank you for listening. Take care and good luck with this assignment.